down in Colombia. And we got to know Brian and his team about a year ago and kind of just struck up a great friendship and kind of partnering with things and referring business back and forth to each other. And he kept telling me about this CTO Insights event that they were doing in Miami. He's like, you just seem like somebody that kind of is like-minded about business and getting people together. So he invited me a couple times, couldn't make it. He invited me to one in November, which is kind of their end of year thank you for their speakers that had spoken throughout the year. And so I was able to get down there. It was like a quick in and out trip, and it was an awesome night. The community that they had built. In fact, Hugo is here tonight from Miami, who was actually one of the speakers. I met him there a few months ago as well. And so we got the team together, wanted to start it here. So this is our very first one. So you guys are our inaugural group. And really the premise behind it is just a small group of tech professionals in a different type of setting, a little bit more laid back. Once you guys up there, food, drinks, feel free to get up, get drinks as the speakers are speaking, and then giving you guys a chance as well to get up and speak about something that's relevant to you, right? There's kind of no agenda, there's no format. Every speaker is always a little bit different with kind of where they go with it, if they have a presentation. And so we're really excited about this. So our plan is to kind of do these at least 5 or 6 times a year. So you guys will continue to get the updates as we plan them. So thank you for coming. And I get the pleasure of introducing our first speaker here in Tampa, Azad Ratzki from Blue Grace Logistics. I've known Azad for probably 7 years. I think Amy has known him probably
14, 15 years
yeah.
now, I think. Yeah.
Very, very long time.
Yeah.
So we're excited, and he's gonna take it away.
All right.
Yeah.
Thank you.
Yeah.
Well, yeah. Get this on really quick. Make sure I get clipped in. Good? Yeah? Okay. Well, first of all, thank you everyone for joining us tonight. My name is Azad Ratzki. I think some of us have met. Probably worth giving you a little bit of background before you dive into the presentation a little bit. So my name is Azad Ratzki. I'm the CTO of Blue Grace Logistics. My background, I may not look it. 25 years in software. Started out as a software engineer. Started at a very young age. Pretty much been my entire life. Since the age of 10. Started out with an IBM XT, just to give you guys an idea of where I started out in QBasic, then Turbo Pascal. Eventually got into C when that was really getting big, and then C++, and eventually got into all the other stuff, Java, C#, et cetera, as it all came out. And so kind of with that in mind, my journey in computers really kind of ramped up when I was in my teens, and I was basically a major contributor to a Super Nintendo emulator of all things back in the day in the 90s, and reverse engineered the digital signal processor into assembly for emulation. And so that's kind of giving you an idea of where my background is, maybe a little bit of credibility around that. So I am definitely a software engineer by trade, but as far as the CTO role goes, I've been in the CTO role since about 2011, right? And we're 2025 now, right? So that's comprised the other part of my life. Still very much a hands-on CTO. As far as this presentation goes, for starters, I wanted to make it interesting for us, right? We're all technology professionals, and we all have different levels of technical expertise in a lot of different areas. But I want to make this, kind of widely digestible, right? And take us a little bit on a journey. It's all about AI. It's all about my own personal opinions on what the engineer of the future looks like, and even the business professional, and maybe some parallels to what we've seen in the past. All of us, I think, here have been in the industry for a long time. So we've seen a lot of this kind of cyclical stuff happens where big thing comes in, huge change happens, dynamics change. The same role might be called something else, but maybe augmented with additional responsibilities that weren't there before, et cetera. Most importantly, feel free to interrupt me. I want this to be something, I don't just want to be preaching, I don't want to be telling all these things, but definitely feel free to interrupt me on any of this stuff. And like I said, my opinions on some of it. So I think kind of to start this conversation off and to really get us moving in that direction on AI, it's probably worth talking about how the role of a business professional and an engineer, right? Two things. One is an engineer is a business professional, but a business professional might not be an engineer, obviously, have changed over time, right? Even if we look at the smartphone revolution, right? The average business professional and their expertise in using computers was a lot less prior to the smartphone revolution. Now, these days, right, we see with everybody using a smartphone, everything has changed. Even the average business professional is way more advanced at using computers than their counterparts were in the past. I think for the engineers, the same thing has played out. If you go back, right, when programming, when people were programming initially, you were writing software and you didn't really have many tools. You were just trying to figure things out. You were trying to write a program, whether it was an assembly, a procedural language, different things like that. And then you saw things like libraries come along. And libraries were this huge revolution. You could speed up your work. You could do things much faster than you did before. And that same evolution happened, right, when we went from libraries to frameworks. Now I could build something much faster that had all these constituent pieces wrapped up nicely. I think you could take an example like that. You could take even the example of something that is not programming related, and you could take something like Photoshopping, right? When Photoshop first came out, right, there was a lot of controversy around it. You had a lot of design professionals that saw it as, kind of, something dirty and something that, you shouldn't really be using if you're a true designer. You shouldn't be using AI and assistance with AI if you're a true programmer. You shouldn't be using a large language model or a chat GPT to help you write that paper that you were going to do or that news article that you were going to do if you're a true journalist, right? We see this all the time, and it's the same thing that plays out as every single time. It just happens in a cyclical way every generation, right? The tools of now become the tools of the past because everyone eventually adopts them. You can either adopt the tools at the time and basically learn to increase the quality of your work with those tools dramatically and become a so-called artist, a better artist with those tools, or you can be staunch in your denial of them and basically get left behind to some extent, right? You never really get to maximize your full potential by using those tools. So I think that's kind of the premise of this conversation, and we'll get into what I think the engineer of the future is going to look like and what's some of the technologies that are popping up that we're all probably seeing, and some that I'm specifically seeing as it relates to AI. We'll get into that in a second. But I think when we talk AI, I really wanted to take us at least a little bit on a journey to maybe tie into what I just talked about, which is how we got here, right? I mean, we all are talking about large language models now, right? Everybody here has used ChatGPT at this point. What are we, like 2 years into ChatGPT, right? What fastest, most exponential growth that we've seen, even in our industry, where things change rapidly all the time. This kind of adoption is nuts. It's absolutely crazy. I actually had the privilege of going to OpenAI back like about a year and a half ago when they opened up their new office, and it was a sight to see. You basically had like diplomats from Japan. You had all these dignitaries from different governments all standing, waiting to get their time to talk with the team at OpenAI. It was a really, really crazy scene to see in this tiny little office. And I knew at that moment, looking at that, right? I mean, you knew that this was going to be massive. And how we got here is even more bizarre, right? And I think that's the point I wanted to make, and the story I want to tell is that you look at the current, you look at ChatGPT, you have to go back to I think it's about I have it noted, I think it's 1943 when the perceptron was created, right? So not to get, I think we're all technical, but not to get super technical, to keep this a little bit light, right? You have the first concept of how do you simulate a neuron, right? How do you possibly get a computer to think like a human brain or approximate it? And that was the perceptron. And it was never really completed. It wasn't at least completed to an extent that it was initially planned, the hardware, right, to try and simulate a neuron, to see if you could get a computer to think like a human brain to some extent. And then in 1957 I think it was an IBM 304, they tried to simulate it in software. And at the time, I think we all know, right, computing power was a fraction, 1/1 millionth of what it is today. And they attempted to do the same thing, and it didn't really turn into anything. Decades go by, nothing really happens with these perceptrons. We implement all different forms of regression techniques to try and simulate artificial intelligence. We do heuristics, we do all these different things, so-called AI, but it never really gets to that point where it seems magical almost, like what we're seeing right now. Then you have some engineers at Google that end up basically putting together, in an attempt to try and get image recognition and language translation better at Google, they end up putting this paper together called and they put this model together. There's a style of convolutional neural network that uses the whole perceptron concept, but then it layers it many times over using the available computing power that was now available. It's called AlexNet. And they used it for their purposes, but they didn't really take it to the next level, right? They weren't salesmen, they were engineers that had researched something, had proven out a concept, and then had worked with it. That paper that they created was the foundation of what we see with ChatGPT. That model, that thing, was where that all started from. And then you saw a group of individuals that saw real potential in something and take it to the next level, which also makes it that much more interesting. And you see why Google is trying to play catch up in some of these different ways with their Gemini model and everything. They basically created what their competitor has now taken to the next level, and then it has now spawned this massive revolution. Once again, in 2 years, we go from basically models that had what they have, but then you have ChatGPT, or you have the OpenAI team that comes along, and they just spend a lot of money and computing power to basically train this thing to a level no one had trained anything before, and they get this really impressive result. Interestingly enough, too, the more you learn about the large language models, the more you understand that they still fundamentally don't understand fully how some of them work internally, right? It's the hardest thing to debug because you're talking about millions upon millions of layers deep. So to try and figure out why this thing is working and thinking the way it is even harder. We know how to make it, but we don't really fully understand how to completely rationalize what it's giving us. Really bizarre times when it comes to that. So just kind of going forward from that, you see these generational leaps. I think the way I personally have looked at it, right, is anytime I see the average person talk about a technology and look at it as magical in any way, shape, or form, I think we have all seen this, right? Then you know usually it's going to be something pretty big, right? If it's magical and they don't really actually understand it fully, but it's impressing them beyond belief, it usually ends up becoming the big thing. The smartphone was a perfect example of that. It's like, oh, I have this thing, I can do all this stuff with it now, and it becomes addictive almost. The same way with ChatGPT. This also is a good litmus test for when you see things like blockchain come along, and you see these other fads that we see in our industry come along. They don't really stand the test of time because they don't elicit the same reaction, I would argue, right? And I think this is kind of waxing on some of my thoughts around this. But getting back to the original point about these models, how we use them, what the future looks like with them, all the stuff that I mentioned I think applies, right? It's a new tool. And so on top of being a new tool, on top of learning to take advantage of that new tool, you also have a whole ecosystem that's being spawned around it. And so one of the interesting things that's happening right now that you're seeing in the AI space, and maybe some of this applies, right, to our worlds where you guys are working with teams and you're looking at automation, everything is obviously you've seen agent-driven AI solutions, right? So we started out with these large language models. I can talk to it, I can chat with it, but that was it. Then you end up getting this concept of memory. Okay, it has memory now, so it remembers what I'm talking to it about. And then you get this concept of what's called embeddings, which is I can basically dump my entire treasure trove of business documents or companies' documents into a database, into a vector database to be specific, and now it can go search that information when I need it. Then the next step on top of that was, well, I want it to be able to go arbitrarily search the web for me, right? Retrieve, access, those kinds of things. So that was built on top of it, right? And so this is all, once again, in 2 years' time, roughly speaking, give or take a little bit, right? Every piece keeps adding up. Then the next was, I want agent-driven AIs. I want AIs that can basically go assign themselves tasks and then go spin up other large language models to go fulfill those tasks, and then go search for documents, and then go search the web, and go do these different things. One of the biggest frameworks that we see for automation, and we're implementing it at Blue Grace in different ways. We're kind of still trying to find our niche, probably just like everyone, on how we can apply automation through large language models. Document comprehension is probably one of the biggest things, one of the easiest, lowest hanging fruit, obviously, right? They're very good at that. Plenty of other different situations. You start integrating telephony and stuff and having a large language model speak to a customer. That's also something that we've implemented. But one of the frameworks, going back to frameworks, that started, that came out, and some of you may have heard of it, is called LangChain. So this is basically underlying, you see all these products coming out for AI. Every one of them, for the most part, up until this point, was really powered underneath by a combination of either the ChatGPT models or some other model, and then LangChain on top of it to basically create the workflow. The whole concept of you being able to chat with something and then you being able to upload a document and all these other different pieces. So we sped up the workflow. Obviously, for an engineer, they need to understand how to work with this. I know a lot of engineers who haven't touched something like LangChain. But you keep on moving forward with that to just show how fast this stuff is moving. Another one that is another technology has now hit the scene recently, and I've just started looking at it, just started working with it. It's called MCP. So, yeah, going back, and it sounds like you guys have heard of it, right? Going back to, I want my model to be able to do this, and this. You now have MCP, which is Model Context Protocol, and so Model Context Protocol, not to go too deep into it, basically says, okay, well, let's scrap even the code and the complexity to some extent of having to set up something like a LangChain just to be able to go do what you need to do. And instead, let's create a protocol that just lets AIs or large language models talk to services, arbitrary services at will when they want to, and let's standardize it. And just like we saw with HTML, and just like if you go back far in time, right, I think we all know this, once standardization starts to come into the fold, then it's even more exponential. You start seeing derivative technologies break off. You start to see all these different things spin off. And that's where we're at already right now with these large language models. It's moving so fast, it's hard to keep track of. Already with the MCP stuff that we're seeing, you're seeing companies and products basically implement MCP out of the box and say, okay, just let your model talk to us. It already knows how to talk to us. It will know and understand what it can get from us. So kind of going back, I think, to, I think a little bit of the premise of this conversation is, what does the engineer of the future look like? I think we can determine right off the bat that, just knowing how to write software, or just knowing how to solution for a problem, or just knowing how to do X, Y, and Z, it never was the only thing that an engineer needed to do, but it's becoming that much more, honestly, in my opinion, less important. Being apt is going to be the most important thing, because it is changing so fast that their ability, and the value, by the way, right? If we look at what we're seeing in the industry right now, you guys have all heard the term vibe coding. There's a lot of kind of almost controversy on how effective vibe coding is. But the short of it is, for anyone who doesn't know what vibe coding is, basically it's just the idea that whether it's an engineer or a non-engineer, business professional, they're basically just writing a piece of software or a product or a project that they want to create with the model doing it for them, right? It's like I'm talking about, I want to build an app that has a spaceship in it that can chat with people, or I want to build a game, et cetera, et cetera. And these models can build it for you now. That's at least what vibe coding is in theory right now, right? So, but the reality is, if you take something like that, you still have to have, and you're still going to need to have, an individual that can put something larger and broader together, right? You can do vibe coding and do all that, but I am definitely the type of person, I would say, that doesn't hold dear the notion that the engineer of yesterday isn't replaceable. And when I say replaceable, I don't mean the person. I mean what they were doing and how they were doing it specifically. I think a good engineer, and this is what the engineer of the future needs to be like, a good engineer is one that says, okay, this is the new path forward. I still have big ideas and big things I want to deliver on. Let me use that tool to go do it. I might vibe code this, I might do that, I might not do that, et cetera, et cetera. But they're going to have to be able to learn faster and faster. And that becomes the primary skill, I think, that you measure the engineer of the future in, right? Whereas I think if we looked in the past, something kind of cliche, the quintessential Google interview, right? Can you do this? Can you do binary search tree? Can you do that? That proves that you're a good engineer. That proves that you're going to be a good software engineer for us. That's kind of moot at this point, right? I mean, at the end of the day, you don't need to prove that anymore with something like a tool like this anymore. Rather, you need to be able to prove that your mind is set up to solve problems intelligently. And I think that's one of those things that for all of us that have hired a lot of different people, right? It's something you can see shining brightly in someone right off the get-go, but it's also the thing that you can be hard to detect sometimes, right? It's a lot less straightforward. You're not going to get it on pen and paper. It's a lot more subjective in different ways. So I think, going back to this concept of the engineer of the future, and maybe speculate a little bit on what we see here. We know that things like MCP are going to connect a lot of these products. So let's assume with the changes that we're seeing AI related right now, things like MCP hitting the scene, all of that, another 6 months, what do we have, right? We have DeepSeek that we've all heard of now at this point. I personally run it on my machine to see what it was like, right? Couldn't run the full model, the massive model. You need a lot more memory for that. But I'm running a local model of it, and it's incredibly fast, right? And so that was already another generation. We started with ChatGPT, now we're at DeepSeek. Now they're all competing with each other. Who has the best model, who can make the best, fastest one, et cetera, et cetera. And then you have things like MCP that are going to come in, that are going to automate more and more of it. And so I think for all of us that have to look for automation in our businesses, have to look for that savvy engineer, that apt engineer, I guess where I'm going with this is that, we're not going to necessarily be able to keep up entirely with it, but there are plenty of opportunities for us to implement some of these things. And I think going back to the concept of automation through telephony, through document recognition is one of those. But the next step is going to be figuring out how can you automate complex workflows, right? And one of the first things that you could do in your company, depending on what kind of technology you're using, what kind of software you're building, if you're building software at all, is going to be the implementation of that MCP protocol as soon as you can, right? Because that is the next step right now, right? So I'm just kind of latching onto that right now to say that that's exactly what we're having to do. We need to do it. I think it's similar to anybody that's built APIs and web technologies for a long time. When things like Open API came on and all these things, you have to SOAP, if anybody knows that, you have to start to implement those things. And I think, the next logical step that we're going to see is basically multiple agents running concurrently, scheming on problems that we have. And I don't think it's far away at all. I think you're looking probably at about less than a year before an off-the-shelf component comes in that will basically allow for that, right? Where you basically have multiple large language models running at the same time. You could do it right now. It's not that you couldn't. But I think for all of us, depending on what role we're in, you're looking for a ready-to-go product sometimes to automate the business. I don't think it's far out at all. I think you're going to see some of it hit right very soon, because that's the next logical step. You don't just want one model. You want different models tuned for different things, all working in tandem together as agents, figuring the different things out. So biggest steps, and these are the steps that we've taken to put something a little bit more practical in place, is my opinions, get in your organization, get all your documents either embedded into vector databases as soon as you can. Otherwise, there's no way you can leverage your data. So you might have ideas of, I have Jane or John in department A and B, and I would love to be able to automate that workflow that they do. But the reality is if you haven't figured out how to get all your documents of your entire company and all of that information, exchanges, et cetera, into an embedded database, whether through different products. I mean, you can do it through Office 365 now, you can do it through Google Workspace, you can do it through all these things. There's a lot of ready off the shelf. But if you haven't done that yet, my argument to you is that's step one. Step one is getting all your data pumping constantly into a database that the LLMs can work with before you start, at least my opinion, before you start really pondering these complex agent workflows that are built off of what used to be human processes. Because that gets more, that's still complex to some extent at this point. That's stage one. Then you start looking at how can I leverage workflows and processes that focus primarily on document recognition, understanding concepts from documents that a human was doing it. And I can write prompts. You can write prompts effectively that format and standardize what it's seeing, and you can save those things, right? That's like stage level 2, in my opinion. And then you get a little bit further and you start looking at stage 3. And that's when you start actually saying, okay, I am going to use things like MCP, whether it already be implemented by a tool that my company is paying for, or whether it be my team that's going to implement MCP on top of tools that we use, and I'm going to let the model now talk to MCP to my things. That's kind of like the third stage. You got like an Amber Alert? Yeah? Yeah, that's good, yeah. And so that's kind of the approach that we're taking, with the introduction of these. It's also worth noting, I think, going back a little bit more to the software side, I am biased, right? It's my background. I think creating a culture within your engineering groups and your technology professionals within your organization of embracing these tools is one of those things that's like, I think we've encountered it in so many different ways with every technology that we touch. You will have people that are just absolutely refusing to use that. They feel they have too much pride in their work, and they see it as something that's like tainting their work. And I just think, it's good to remind and build a culture, and it's what I try and do, of reminding people that that's what technology is. I mean, that is literally what technology is. Technology is not about having a craft and then staying and doing it the same way. That's a beautiful thing too, right? If you're the Japanese craftsman that makes the sword in the exact same way since the 1400s, that's a beautiful thing. You can embrace that. But it's a different thing. It's not the same thing. Technology is literally the idea of applying a new concept and something new and continuing that cycle over and over and over again and advancing because of it in some way, shape, or form. So if you find yourself as a technology professional that's refusing to adopt a new technology because you're too good for it or because it's going to taint your work, you probably need to question why you're in technology in the first place, is I guess my argument, right? Not to sound too arrogant about it, but I think that's a fair thing to say. And so, I think building a very strong culture and getting people to jump right in. We saw this with GitHub Copilot. I think a lot of people have had their people touch or dip their toes in that. That was a great, actually, way for developers to dip their toes in that kind of assisted AI initially. But once again, going back to the business professional, now you're seeing it spread everywhere, right? I mean, I think we're all, I'm completely fine admitting it for myself, right? I use it extensively for ideation, for testing summaries, executive summaries. If I'm going into a board meeting and I have a lot of information, you know what? I might not be the best person at summarizing that information. I'm fine admitting that. And it can do that very well for me. I don't think there's no point in being bashful around that. But I think to tie this all together, I think what you end up seeing is that the non-engineer, aka just the business professional, and the engineer start becoming one and the same thing, is really what ends up happening. It is what we're seeing. And I don't think there's any going. Go ahead.
Sorry to interrupt.
Yeah. Yeah.
So we are beginning to adopt AI tools in our product development, software development process, back office, and embedding in our products, but we're pretty early on in the process. So we're starting to distribute tools to everyone and do lunch and learns on how to